All right, let me try a video solution here from chapter 15. It's number 24 here. And again, a lot of these, and this one in particular with the standing wave pattern, it's probably best to begin by just kind of drawing kind of a standing wave pattern. And if you've watched the other videos from number 24 and 42 and 48, I kind of draw them and say there's kind of two ways of looking at it. You can just leave it like this, which is kind of nice, except you know that that's kind of a picture at a moment in time, so it changes. And if you just leave it like this, you're not really sure if the crest here should be moving, so it's a traveling wave, or if it kind of diminishes down a little bit and the crest kind of stays where it is, it just gets smaller and then even inverts. And so this would be my third picture. So this is not just one big picture. These are actually three pictures drawn on top of each other, trying to show what happens next. Then the crest would go the other way around, and then the whole pattern would keep repeating itself first of all in the other direction, and then repeat from the very beginning. And so this is kind of nice to draw. It gets kind of confusing because sometimes you can interpret that as a complex mess of a string, but it's really only supposed to be one string, and that's a picture at different moments in time. So a lot of times I'll do both when I try to explain to the students. You can look at it this way, or you can look at it that way. And whoops, I didn't draw my spacing equally. Hope that's okay. So the real key, though, is if you look at it this way with four different pictures at different moments in time, you begin to see that the crests don't move. That's why they're called standing waves instead of traveling waves. And that there's these magical points called nodes that don't move ever at all. They don't go up or they don't go down. And so the crest doesn't go left or right. It just goes up and down. And so those are called antinodes here, these points that would move a lot, the most. So we've got nodes and antinodes. Okay, so in this picture here, but we've only drawn it at one moment in time, all these dots would be nodes. And so we're drawing all the nodes. And these points here, crest, and then for that matter, the trough, because that trough would come up and become a crest, and this crest would go down and become a trough. And so you got to kind of draw a vertical line when you talk about the antinodes. Okay, so the key here for this problem here is it says you have a 2-meter long rope, and it is tied to a very thin rope. So maybe it looks like this. You've got this real heavy rope that goes for a while. And they don't really say. But then is tied to something that is light and easy to move. So maybe that would be the standing wave pattern for this. But here's the real key to the problem here is they're saying that this is pretty much free moving because this one is so light. So this is going to move the easiest and the most. So this point here would have to be an antinode. And that's why you got to tie it to this light string. You normally just can't have a free end of a rope bouncing around here, but this end is tied. So 2-meter long rope is tied to a very thin string so that one end is essentially free and the other one is locked into place. So the one locked into place would be a node. So maybe it looks something like this. Maybe I'd say, okay, this has to be the wall here. This has to be the node. And then the antinode could be here, could be here, could be here, could be here, could be here. A lot of different possibilities. It says what possible wavelengths will be produced. Okay, so if it was this, if it would go from the node to what I'll call the first antinode, remembering that from a node to another node's a whole, that's kind of a terrible way of saying it. I was going to say it's a whole half wavelength, but a whole wavelength would go to here. This would be 1/4 of it. So this would say something like L would have to be 1/4 of a wavelength. Now, the other option is it could go to this antinode. So it would start here and that'd be a half with another 1/4. So L could be 3/4 of a wavelength. Now, it could be a node and go to the third antinode, which would be here. And if you look, that's one wavelength and another quarter. So it's 1 1/4, although let me write it as 5/4 so you can see the pattern. And so from one antinode to another, we keep increasing by a half wavelength, which is 2/4. So we start with an offset of 1/4, so it goes to 3/4, 5/4, and the next one would be 7/4, and the next one would be 9/4. You could even write this as L equals to M quarter wavelengths, where M is only the odd integers, 1, 3, 5, 7, 9, ... Now, they did give us the length of this. This is a 2. So if we bring the 4 over, that's an 8. Bring the M over, and that's our different wavelengths. So our different wavelengths are 8 divided by 1, 8 divided by 3, 8 divided by 5, 8 divided by 7, ... Or up here, you can just say 8 divided by M, where M is the odd integers. ... So, however you want to phrase it, but again, it's based on these standing waves and a node and an antinode. And number 24, I decided to do third because I think it's a little harder to see. The other two I did, you might want to look at 42 and 48 before you tackle this one, because seeing it from node to node is a lot easier than node to antinode. But it needs to be visualized, and so hopefully the video helps.